Okay guys, this is a review over electricity, so I'm just going to start with number one. Electrical potential of 1 joule per coulomb is equal to, the answer to that one should be a volt, D. And the reason for that is, remember that a volt is essentially the potential energy stored per electron in the system. So the way you would write that would be joules, because that's the unit for potential energy, and the electron, the charge, is a coulomb. And so it's a joule per coulomb, or a volt. Alright, number two. Two charges are 2 meters apart, and if the distance between the charges decreased to 1 meter, what happens to the force? Well, you know the force is originally 2 times 10 to the negative 5th newtons. So the important thing here is that the radius initially is 2 meters, and that the radius or distance is 2 meters, and then it drops to 1 meter. Now the relationship here, you could say it drops by 1 meter, or you could say that it is 1/2 the original. So what happens if we half the distance? Well, the relationship would be, if we plug in everything as ones to represent the original numbers, we would get a 1 for this original force, okay? So it's a multiplier. And then we're going to change what we changed. We changed the distance. So we're going to do 1 times 1 times 1, because none of that stuff changed. But what did change was the distance, so now it's 1/2 squared. Half the distance. And if we do that, we get 4, which means this is the factor that we have to multiply our force by to get the correct answer. So 4 times 2 times 10 to the negative 5th is 8 times 10 to the negative 5th, so the answer should be C. Next up, as shown in the diagram, a neutral pith ball is suspended on a string and is attracted to a positively charged rod. During contact with the rod, the pith ball should lose electrons. And so the reason for that is, the answer should be A. The reason for that is this thing is positively charged, right? So if you bring something that's neutrally charged into contact with it, this guy wants to pull electrons to it, and this guy would then lose them. And what would happen is it would pull it off until it became neutrally charged, and then the pith ball would drop away. But the pith ball loses electrons, and the reason you lose electrons is because you can't lose protons. Remember, losing a proton is a very damaging thing to an atom. It starts a nuclear reaction, and so it changes the atom fundamentally. But you can lose all the electrons you want to, really, and it won't hurt it too much. Next up, number 4, a circuit has a current of 5 amps flowing through it. How long does it take 30 coulombs of charge to be transferred? So on number 4, you're going to do current equals charge divided by time. So we know that the current is 5, and we know the charge is 30, and we're solving for time, and time should equal 6 seconds. So the answer should be B. On number 5, shown are copper wires with identical cross sections. Which wire will have the least resistance? Remember that high temperature and the longer it was and the higher the temperature, the more resistance. So it's definitely not A or C. So it's got to be one of either the 1 meter rods. The 1 meter rod that's colder will have the least resistance. So that answer should be B, because all the other factors involve the length and the temperature. High temperature means more resistance. Longer rod means more resistance. So A and C are ruled out for that reason, and the higher temperature rules out D. All right. So going on to 6. Number 6. The circuit contains a power supply and 2 resistors as shown. What is the voltage across resistor R? Well, remember that in a series, if you have 12 volts, then as it comes around, if this one loses, if we know this guy loses 4 volts, then we know this next guy has to lose the remaining voltage. So if this one lost 4 volts, then this one would have to lose 8 volts, because once you get back around here, you've got to have 0 volts. And there's 12 volts total, so 4 volts gets used, there's 8 more volts that have to be used. So the answer should be A. And that is number 6. Number 7. If the resistance of a circuit is doubled and the voltage remains unchanged, the current flowing in the circuit will be. So we're dealing with Ohm's law, and it says that we double the resistance, okay, and the voltage stays the same. So it has to happen to the current. Well, we don't have any numbers in the formula here, so I don't need to have any numbers here. So I've got to do something to the current that cancels out the 2. And if I half the current, it cancels that out, so we're left with V is equal to IR again. But I have to half the current in order for that to happen. So the answer should be A. Number 8. The answer should be 800 joules. And this is how. You would first do V is equal to IR to find the current. Okay, so you know that the voltage is 10 and the resistance is 5. So you're looking for the current. The current is 2 amps. Okay, that gives us the current. Now we go for power. Power equals voltage times current. So power equals 10 times 2, which is 20. 20 watts. Now remember that power is also equal to the energy used divided by time. So 20 watts equals the energy divided by 40 seconds, and this gives us 800 joules. Okay, that's number 8. Number 9. Number 9. What is the voltage of the power supply shown? Well, we know that the little things that say 5 and 10 are showing us how much the voltage dropped over those resistors. So there's only 2 resistors, and there was 15 voltage drops total. So the amount of voltage in that system should be 5 plus 10, which would be 15 volts. Number 10, as temperature of the copper wire is decreased, its electrical resistance would increase. So the answer should be B, because lower temperatures are better for the wire. All right, next one, 11. On number 11, which graph indicates the relationship between the resistance of a wire and its length? The resistance of the wire should go up as the length goes up, and it should just be linear. It's just a linear relationship. So the answer to number 11 should be B, because the longer it is, the more resistance it has. It's a linear relationship. Number 12. If a wire of cross-sectional area A has a resistance of R, then another wire of the same material with a cross-sectional area of 2A will have a resistance of. So it's essentially saying we double the area, what happens to the resistance. It gives you a little formula here, but the important thing to note is that the area is in the bottom of the formula. So if we double the area, it doesn't really matter what's up here, we'll just call it a 1. But if we double the area, we get half the resistance. So it should be R over 2. So number 12 should be C. All right, number 13. At room temperature, which segment of copper wire has the highest resistance? Okay, so first of all, we're looking for the highest resistance. Remember that a small cross-section, small area equals big resistance. So we can rule out the ones with the larger area. So I'm going to just abbreviate that. So we know that it's not C or D. So we want the highest resistance, so then we also need to know that we also need to know the longer the uh, the wire, the more resistance. So we need a small cross section, so it's either A or B, and we need the longest one, so it's B for sure because it's got the longer length. All right, number 14. If the potential difference across a 12 ohm resistor is 4 volts, the current is, so we would do V equals IR, and then we would do 4 equals I times 12. And so 4 divided by 12 would be your answer. And that's the current. 4 divided by 12 is also 1/3. So the answer should be A. Number 15. Number 15 says the ratio of potential difference across a conductor to the current in the conductor is called. So you've got to figure out the ratio that it's talking about. Write it down what it's asking for. First thing you need to know is, remember, potential difference is voltage. So we've got voltage involved. And then it says the ratio of potential difference to the current. So voltage over current. What does that equal? Well, if you'll remember, V is equal to IR. Voltage over current would be equal to the resistance. And so the answer should be B, resistance. All right, 16. Which graph represents a circuit element at a constant temperature that obeys Ohm's law? The answer should be D, because V is equal to IR. If we imagine V as the Y part of our equation and the I as the X part, then what we should notice is that R becomes the slope, M. And so we should have a linear relationship here with voltage on the y-axis and current on the x-axis, and resistance would be the slope. Number 17. Number 17. An electric iron draws 5 amps and has a resistance of 20 ohms. The amount of energy used by the iron in 40 seconds is. Remember that for energy we need power equals energy over time. So we need to figure out power. Power is equal to voltage times current. So we don't have voltage, so we need to find voltage. Voltage is equal to current times resistance. So we do know that one. Current times resistance would be 5 times 20, which is 100. So 100 volts. So now I can do 100 times 20, which is 2,000 watts. And then I can use this formula now, and we can do 2,000 watts equals energy over 40 seconds. And we should get a significant number. Hang on. 17. Let's see, messed up somewhere. Hang on. So voltage. Please excuse me, I screwed up. I should have plugged in 5 here. My bad. I plugged in the wrong thing. So this then is no longer 2,000, it's 500, which makes more sense, 500 watts. That is now 500 watts. So we do 40 times 500, and we get the answer D, which is 20,000. Or, yeah, 20,000 joules. Sorry about that. 18. What is the approximate amount of electrical energy needed to operate a 1,600 watt toaster for 60 seconds? So remember, power, this is number 18. Power is equal to energy over time. So we know it is 1,600 watts. And we know that it is using up some amount of energy. And we're wanting to know how long it would be in 60 seconds. Okay, so we would do 60 times 1600, and we would get D. So 60 times 1600 would give us D. 19. In the diagram, L is the unit of length, and A is the cross-sectional area. Which copper wire has the smallest resistance? So again, we should know this by now. Longer it is, the more resistance. So it's got to be one of the shorter ones. Bigger the cross-sectional area, the less resistance. So the answer should be C. So number 19, the answer is C. 20. Compared to the total resistance of two 5-ohm resistors connected in series, the total resistance of two 5-ohm resistors connected in parallel is, well, let's check this out. So if we connect them in series, it would be 5 plus 5 equals 10. If we connect them in parallel, it'll be 1 over 5 plus 1 over 5 equals 1 over R total. So this would give us 2/5 equals 1 over R total. Remember, you have to flip it, you got to invert it, so it'd end up being the resistance total would be equal to 5 over 2, or 2.5 ohms. So in parallel, it is less. The total resistance in parallel is less, so the answer should be A. So number 20 should be A. 21. The diagram shows a resistor of 5 ohms and a resistor of 10 ohms connected in parallel. What is the total resistance? So on 21, you're doing 1 over 5 plus 1 over 10, plus 1 over 10 equals 1 over R total. And you would end up getting 3/10 equals 1 over R total. R total would be equal to 10 over 3, or 3.33, which gives us less than 5 ohms. So the answer should be A. 22. 22. Base your answer to the following question on the diagram given. The voltage drop across R1 is, so we want to know what the voltage drop across R1 is. We know that the current is 8 amps, and we know that the resistance is 1 ohm. 1 ohm. So, to find the voltage drop across that first resistor, we would just do Ohm's law, but specifically for the first resistor. So the voltage would be equal to 8 times 1, or 8 volts. And that would give us an answer B. 23. 23. What is the total resistance of that circuit? The answer is, you just do R1, since it's in series, it's R1 plus R2 equals R total, so that should be 1 plus 2 equals 3. So the answer should be 3 ohms, which would be C. 24. 24. In the circuit diagram shown, which is the correct reading for the voltmeter on 2? Alright, this is kind of tricky. So we know that we have a total voltage of 110 volts. And remember that as you go around the circuit, you have to use up all that voltage. Well, we used up 20 volts on V1 and 20 volts on V2. So how much voltage is left over? We have to use it all up. So we've used up 40 volts so far. So 110 minus 40 volts is equal to 70 volts. So that's got to be the resistance on that middle one there, V2. And that is indeed the answer. So the answer should be B as in boy. 25. A 5 ohm resistor, a 5 ohm and a 10 ohm resistor are connected in series. The current in the 5 ohm resistor is 2 amps. The current in the 10 ohm resistor is, so if they're connected in series, the current is the same throughout. So that if one has a current of 2 amps, the other one has to have a current of 2 amps. So the answer to number 25 should be B. And then lastly but not least, 26. What we want to do is we have a 5 ohm resistor, a 20 ohm resistor, and a 24 volt source of voltage, and they're connected in parallel. A single ammeter is placed to read the total current. Where would you need to place the ammeter? So here we go. We've got a 24 volt battery, or whatever it is, power supply. And then we've got two resistors. Connect that back. Two resistors. And one is 5 ohms and one is 20 ohms. Where do we need to put that ammeter? Would the ammeter go here, or here, or here, or here? Well, remember that in a parallel circuit, each branch here will get its own current. So we can't put it there. So the best place for us to put it is right here. Is going to be our best bet. So put the ammeter right there, and this should give us the total current, because it'll have the current, it's already flowed through both passages, and it reconnects and adds together there. Alright, so that'd be the best place to put it. Alright, hope this helps. If it doesn't help, I apologize. If you have any questions, feel free to let me know.